Hello all, welcome to Cyber Platter. This is a video on ISC Square CCSP certification that will help you prepare for the exam. Today we will cover a portion of domain 1, that is cloud concepts, architecture and design. So this is the agenda for today. We will discuss about evaluating cloud service providers. This includes verification against certification criteria and subsystem or system product certifications. This is the first topic, that is evaluate cloud service providers. The key point to remember here is if it cannot be measured, it cannot be managed. The first question that arises here is why do we need to ensure cloud service providers are certified, right? Because our data resides with the cloud service provider and we trust them to protect its confidentiality, integrity, and availability. Cloud vendors who meet standards criteria are more likely to provide us with the CIA we require, which reduces the risk. Imagine using a cloud vendor with no certifications, right? We know nothing about their capabilities, and trusting these vendors would be high risk decision. No third party audits have taken place to validate anything. So, how do we know if something is meeting standards if we have no data to validate against? That is, how can someone have confidence, awareness, and assurance that cloud service provider is taking the correct steps to ensure that data is secured properly, right? With so many cloud service providers on the market, it's important that you understand how to consistently evaluate them, regardless of service category, development model, or architectural differences. So, now the question is how can we evaluate cloud vendors effectively? Surely there's tools out there to help us do this. Frameworks and standards hold the key here. Why do you think that so many users and entities are still unconvinced that cloud computing is a good option, particularly from a security perspective? This is because there is no single international cloud computing standard or security standard, right? In the absence of cloud specific security standards that are universally accepted by providers and customers alike, we will have to deal with a patchwork of security standards, frameworks, and controls that are being applied to cloud environments. For example, ISO, IEC 27001, 27002, etc. Verification against certification criteria. A critical component of every security program is the ability to audit and verify compliance against certification criteria that may include guidelines, standards, or regulations. As cloud computing continues to mature, the list of regulators and standards looking to certify cloud security grows right along with it. We will discuss some of the important ones here. The first one is ISO IEC 27001. ISO IEC 27001 is an information security standard that was originally developed and created by the British Standards Institute under the name of BS 7799. The standard was adopted by the International Organization for Standardization, that is ISO, and the International Electrotechnical Commission, that is IEC. Most widely known and accepted information security standard, and this is focused on the creation and maintenance of an information security management system, that is ISMS, which ISO defines as a systematic approach to managing sensitive company information so that it remains secure. An information security management system is a set of people, processes, and technologies that manages the overall security of our company's systems and data. By its nature, ISO IEC 27001 is designed to be vendor and technology agnostic. That is, it does not differentiate between them, that it does not view them differently. Remember that even though ISO IEC 27001 is the most advanced security standard widely used today, it does not specifically address cloud security. So it cannot be used as a single source for cloud security. The most recent version of ISO 27001 was published in 2013 and it consists of 114 security controls across 14 domains of security. The domains are information security policies, organization of information security, human resources security, asset management, access control, cryptographic, physical and environmental security, operation security, communication security, system acquisition, development and maintenance, supplier relationship, information security incident management, information security business continuity management, and compliance. The next one is ISO IEC 27002. It is titled Security Techniques Code of Practice for Information Security Controls. It provides guidelines for organizational information security standards, including the selection, implementation, and management of security controls, taking into consideration the organization's information security risk environments. It is designed to be used by organizations that intend to select controls within the process of implementing an information security management system, that is ISMS, based on ISO IEC 27001. It can also be used by organizations to implement commonly accepted information security standards and develop their own information security management guidelines. The security controls in ISO 27001 and 27002 are the same. The only difference is that ISO 27002 explains the controls in greater detail. Now let's talk about cloud-specific ISO IEC standards. The first one is ISO IEC 27017. The latest version was released in 2017. This gives guidelines for information security controls applicable to the provisioning and use of cloud services for both cloud service providers and cloud customers. ISO IC 27017 provides cloud-based guidance on 37 ISO IEC 27002 controls, along with 7 new cloud controls that addresses who is responsible for what between the cloud service provider and cloud customer, the removal or return of assets when a contract is terminated, protection and separation of the customer's virtual environments, virtual machine configuration, administrative operations and procedures associated with the cloud environment, customer monitoring of activity within the cloud, virtual and cloud network environment alignment. Another cloud-specific ISO standard is ISO IEC 27018. The latest version was released in 2019. It is focused on the protection of personally identifiable information, that is PII, in the cloud, and again builds on the existing set of controls within the previously discussed standards, but adds privacy-related controls to the mix. Let's now discuss about NIST SP 853, that is National Institute of Standards and Technology Special Publication 853. NIST is an agency of the US government that makes measurements and sets standards as needed for industry or government programs. The title of NIST SP 853 is Security and Privacy Controls for Federal Information Systems and Organizations. It is a risk management framework. The primary goal and objective of NIST SP 853 standard is to ensure that appropriate security requirements and security controls are applied to all US federal government information and information management systems. FedRAMP. FedRAMP stands for Federal Risk and Authorization Management Program. It is a US government-wide program that was established in 2011 to create a standardized approach to security assignment, authorization, and continuous monitoring of cloud service providers. FedRAMP effectively enforces NIST guidelines for any cloud service provider that provides products or services to the US government. It is known for being a rigorous assessment process. Hence, the FedRAMP model has been a major influence for public sector cloud security programs around the world. PCI DSS stands for Payment Card Industry Data Security Standard. Visa, MasterCard, and American Express established PCI DSS as a security standard to which all organizations or merchants that accept, transmit, or store cardholder data, regardless of size or number of transactions, must comply. PCI DSS was established following a number of significant credit card breaches. It is a comprehensive and intensive security standard that lists both technical and non-technical requirements based on the number of credit card transactions for the applicable entities. Processors are never to store the credit card verification number, that is CVV number, for any length of time. Credit card data should be either encrypted or tokenized. The standard has 6 goals, 12 requirements, and 200 controls. Failure to meet and satisfy PCI DSS requirements can result in significant financial penalties, loss of authority to protect credit card transactions, escalation to a higher merchant level, and potentially greater assurances and compliance requirements in the event of a breach. PCI DSS distinguishes merchants by different levels based on number of transactions per year. There are 4 merchant levels based on the number of annual transactions. It is used to determine the level of compliance required. Merchant level 1 is any merchant, regardless of acceptance channel, processing more than 6 million transactions per year. Merchant level 2 is any merchant processing transactions between 1 million to 6 million per year. Merchant level 3 is someone who's processing transactions 27,000 to 1 million per year. Merchant level 4 is any merchant processing less than 20,000 transactions per year. PCI DSS Goals. PCI DSS standard has 6 goals that generally align with security best practices. Build and maintain a secure network and systems, protect cardholder data, maintain a vulnerability management program, implement strong access control measures, regularly monitor and test networks, maintain an information security policy. 6 goals of PCI DSS are broken down into 12 requirements. All merchants, regardless of level, and relevant service providers are required to comply with all the 12 domains or requirements. Installing and maintaining a firewall configuration to protect cardholder data. Do not use vendor supplied defaults for system passwords and other security parameters. Protect stored cardholder data. Encrypt transmission of cardholder data across open public networks. Use and regularly update antivirus software. Develop and maintain secure systems and applications. Restrict access to cardholder data by business need to know. Assign a unique ID to each person with computer access. Restrict physical access to cardholder data. Track and monitor all access to network resources and cardholder data. Regularly test security systems and processes. Maintain a policy that addresses information security. The 12 requirements list more than 200 controls that specify required and minimum security requirements for the merchants and service providers to meet their compliance obligations. Due to the technical and detail-oriented approach taken by PCI DSS, many organizations outside of the payment card industry trust PCI DSS as a security standard around which they can build their security standards. Many cloud service providers must either meet or support their customers in meeting PCI DSS. These audits are quite common in the cloud space, and understanding this standard is a valuable skill for cloud service professionals. System or subsystem product certifications. While ISO, PCI DSS, FedRAMP, and others are squarely focused on assessing and certifying the security of an organization and its services, being able to certify the security of individual products is essential in order to build secure systems at scale. Many frameworks have been established for this purpose over the years, but two leading international standards are Common Criteria and FIPS 142. FIPS is Federal Information Processing Standard. Government agencies require that services they use be certified under the common criteria and that encryption used to support them be compliant with FIPS 142. Common criteria is an international set of guidelines and specifications for evaluating IS products to ensure they meet security standards for government entities. It is officially known as the Common Criteria for Information Technology Security Evaluation. It needs to be verified by vendor neutral third party. Primary goal of common criteria is to assure customers that products have been thoroughly tested by third parties and meet specified requirements. It is also called ISO 15408. Now let's discuss some of the key components of common criteria. First one is target of evaluation. It is the device or system that needs to be reviewed for common criteria certification. Protection profile. PP defines what does the customer need. It is a template used to design a standard set of security requirements, that is a standard set of security requirements for a specific type of product such as firewall, IPS, intrusion prevention systems, switch, etc. Security target ST defines vendor's claim of the security. It is the explicitly stated set of requirements specific to the capabilities of the product under evaluation. Evaluation Assurance Levels EAL. An EAL is a numeric score that is assigned to a product to describe how thoroughly the product was tested during the common criteria process. The levels range from 1 through 7, with the higher levels providing more assurance of the product security claims. That is, 1 being the lowest level evaluation and 7 being the highest. Let's see what are these levels. Level 1 is functionally tested. Level 2 is structurally tested. Level 3 is methodically tested and checked. Level 4 is methodically designed, tested and reviewed. Level 5 is semi-formally designed and tested. Level 6 is semi-formally verified, designed and tested. Level 7 is formally verified, designed and tested. Common criteria evaluation process. The goal of common criteria certification is to ensure customers that the product they are buying have been evaluated and that a vendor neutral third party has verified the vendor's claim. Note that common criteria looks at certifying a product only and does not include administrative or business processes. To submit a product for evaluation, we need to follow the following steps. The vendor must complete a security target description that provides an overview of the product's security features. A certified laboratory then tests the product to evaluate how well it meets these specifications defined in the protection profile. A successful evaluation leads to an official certification of the product. FIPS is Federal Information Processing Standard. FIPS 142 is related to the assessment and validation of cryptographic modules. A cryptographic module is simply any hardware, software, or firmware combination that performs encryption, decryption, or cryptographic functions. FIPS 142 validated certification was established to aid in the protection of digitally stored, unclassified yet sensitive information. Federal Information Processing Standards are publicly announced standards developed by NIST for using computer systems by non-military American government agencies and government contractors. FIPS 142 assessment is completed by one of several independent third-party labs who rates each product security between level 1 and level 4. Level 1 is the lowest level of security. The basic requirement is that at least one approved algorithm is in use by the cryptographic module. The only physical security requirement is that production grade component to be used. FIPS Level 1 allows implementations of cryptographic modules that execute software and firmware on general purpose, unevaluated operation systems. Higher security levels require that entire operating systems be evaluated by common criteria standards. Level 2. Security Level 2 adds additional physical security considerations to those in Level 1 by requiring cryptographic modules to show evidence of tampering. For example, tamper-evident tape or pick-resistant locks. The goal with this level is to provide visible assurance of a device's integrity. Level 3. This FIPS security level adds even further physical security assurance by requiring that modules take steps to detect tampering and respond by protecting the module and any data within. An example of this level would be detecting that the hardware has been breached and erasing all plaintext data within the module to prevent unauthorized access. Level 4 is the highest level of security, which requires rigid testing and scrutiny. Devices certified at this level require that cryptographic modules are fully surrounded by protections that are able to detect any and all unauthorized access attempts. A successful penetration of the physical barrier requires immediate erasure of any sensitive plaintext data within the module. Additionally, Level 4 devices require that cryptographic modules are protected against environmental attacks. For example, an attacker can attempt to cause a device's security mechanisms to fail by manipulating electrical or temperature conditions of the device. This attack would be detected and responded to by a Level 4 device. This is the end of this episode, and we complete domain 1. I will see you in the next video. If you liked it, learned anything from today's session, please like, share, and subscribe to our channel. Thank you. Bye bye.